Okay, I decided I would just do a quick little note video over 3-4. 3-4 is all about composite isometric transformations. So we're going to be doing reflection, rotation, translations. We'll be doing those, but more than one at a time. So like one shape is going to go through multiple transformations. So if you look and follow along on your notes, we are going to be starting on page, if we look here, page 8. So please go to this in your packet if you're not there yet. We're on page 8, 3-4, composite transformations. So it says a blank transformation. We're going to put composite in there. A composite transformation is the term for when a sequence of transformations take place. So sequence of transformations. If we reflect point A over the x-axis, we would get an A prime. Then if we rotated A prime 90 degrees about the origin, we would get a new image point, A double prime. So again, that we're going to say A double prime because it's showing that it's gone through two transformations to end up there. You can continue that pattern until you would be done with the sequence of transformations. So the first thing that's kind of showing up in your notes here is that it shows you the order of composite transformations and how it can affect what the picture ends up looking like. So this first one, it says we're going to translate the shape or the point A by a vector of 3, -5. So we're going right 3, down 5, followed by a reflection over the y-axis. So first we want to translate it. We're going to take point A and then think of these other 2 points as being labeled as well. We're going right 3, down 5. So you end up that this new shape, this is our original. We ended up right here. And now we're going to take that new shape, that A prime, so there's your A prime, your first image, and we're going to reflect it across the y-axis, which is how you end up over in this third triangle here. If we go and we look at the same transformations taking place, so this one was a translation and then we reflected. Over on the right hand side of the screen, we're going to reflect and then we're going to translate. Again, we're going to translate right 3, down 5. It's the same exact transformations, but in a different order. So you still start with your original triangle here. If we reflect it over the y-axis, you end up with your A prime over here. And then from there, you're going to translate it right 3, down 5, and you end up down here. When you compare transformation or composite transformation 1 to transformation number 2, those two boxes, you can see that the images ended up being quite different, okay? The order matters here, okay? So it says, notice that the two composite transformations result in different locations, even though the same two transformations were performed. Okay, so that's just saying the order matters. Depending on the order you do those composite transformation, your pictures can end up completely different, as we see right there. So now there are some examples to try. What I want you to be doing here then is taking your tracing paper, going through this transformation, okay? So the first thing we're going to do is rotate that shape ABC 90 degrees about point O, followed by a translation of 3, -5. So I guess I should say you should be using tracing paper, or if you want, you could be using coordinate rules. So first you're going to rotate it. If you were going to go look that coordinate rule up, or again, just do it on your tracing paper. Our coordinate rule for a rotation of 90 degrees says that we take point xy, and then it's going to become -y, x. So If you're starting at point A, which is at 2, 8, and you want to rotate it, your A prime is going to end up at negative 8, 2, following this coordinate rule up here. If we start with point B at 7, 6, B prime is going to end up at negative 6, 7. C is starting at 7, 2, so C prime is going to end up at, switch it, negative 2, 7. And so when I go to graph these, negative 8, 2, here's our A prime, negative 6, 7, here's our B prime, and then C prime, negative 2, 7. I graph it there. You can see the transformation that took place then. Okay. So either using the coordinate rules or grab some tracing paper from the front table, go ahead and trace that shape and then rotate it with this as your center of rotation. You'd make your T right here and then you'd go a quarter of a turn to the left. Okay. So let's get rid of that. Okay. So we've done our first transformation, the rotation part. Now it says followed by the translation of 3, negative 5. If you're going to figure out what direction that's going, it's going right 3 and it's going down 5. You could look at this as a coordinate rule as well. It's going to be x plus 3, y minus 5. And now what you could do is take those other ordered pairs, those image points that you have. Let me move this out of the way. So we could, if you wanted to go and find A double prime, you would take that A prime point, put it through this new coordinate rule. So we're going to take our x value and add 3. Negative 8 plus 3 gets us negative 5. 2 minus 5 gets us negative 3. So A double prime is at negative 5, negative 3. And I label that A double prime. Okay, you can go ahead and do the same things with B double prime and C double prime. Or if you are not really into the coordinate rules here, you can also just be doing it by hand. So you're going to take each of those points. So point B right here, go right 1, 2, 3, 1, 2, 3, 4, 5. Mark B double prime there. So B double prime is at negative 3, 2. And then C double prime, we're going to go 1, 2, 3 to the right, 1, 2, 3, 4, 5 down. C double prime ends up there at 1, 2. And again, use whatever, the coordinate rule or just doing it by hand, tracing paper, manually doing it. You just have to find what works for you. I just like the coordinate rules because it's very straightforward for me. Okay. Number 2, it says we're going to translate by the vector 3, negative 5, followed by the rotation. So if you look, we're starting with the same exact picture. All we're going to do now is that we have to do it in a different order. So we're going to start with that translation, right 3, down 5, where we have that coordinate rule, x, y, it's becoming x plus 3, y minus 5. And if you want to start, again, we're starting with the same points, 2, 8. B is at 7, 6. C is at 7, 2. So if I want to follow that coordinate rule, I'm going to take my x value and add 3. 2 plus 3 is 5. I'm going to take my y value and subtract 5. 8 minus 5 is 3. So at 5, 3, I can put my first point, A prime. So at 5, here's my A prime. And again, you can just be taking that point A that you're starting with, go 1, 2, 3, 1, 2, 3, 4, 5, and you can end up at A prime there. Okay. You can use the coordinate rule also, which is what I'm doing. So the next one, 7 plus 3 gets you 10. 6 minus 5 is 1. C prime, 7 plus 3 is 10. 2 minus 5 is negative 3. So at 10, 1, I have my B prime. And let me rewrite that. B prime. And then C prime is at 10, negative 3. So there's my first transformation. Okay. So 10, negative 3, 10, 1, and 5, 3. Now, again, we're going to go with that second transformation. So now we're doing A double prime. The rotation of 90 degrees, we already wrote it in the last example. We're taking xy, and it becomes negative yx. So 5, 3 becomes negative 3, 5. 10, 1 becomes negative 1, 10. And for C prime was at 10, negative 3. It's going to go through that transformation and become 3, 10. So go and graph those. Negative 3, 1, 2, 3, 4, 5. A double prime. B double prime is at negative 1, 10. And C double prime is at 3, 10. Okay, so again, the order definitely changed the way that this looked here. Those two pictures are different because the transformations took place in a different order. Now it says, why do you think order alters the resultant location of A double prime, B double prime, C double prime? Really, I don't expect you to really write anything right here, but what it comes down to is if you think about those properties for reflections and rotations, those are the ones that it really depends on which one comes first, because those are going to change the direction, or sorry, the distance and direction that these points are going to be moving. Sometimes if you translate first, it gets closer to the line of reflection, whereas if you would have reflected it first, it's further away. It's really just changing the distance of these points to either the center of rotation or the line of reflection. Okay. So now we have our notation, which we've been working with the notation on all of these transformations. Remember that you have the three different ones. You have the reflection, and it's going to give you like a line right here, an x-axis, a y-axis, y equals x, whatever line you're reflecting across. So that's a reflection. You have the capital T, which is a translation. That's going to put a vector with it. And then we have capital R, which is your rotation. So when you're looking at this, it says interpreting the notation, work inside out. So when I look at this, what that means is that what it says here, it says we have a transformation happening, a composite transformation. This right here is what it's like a composition sign. What it tells you is that you're composing two things, so more than one transformation will take place. What happens is it says translation of negative 3, 5, and then composed with a reflection of over the y-axis. Now here's the deal. We work backwards. So this right here is the first transformation. And then this right here would be your second. So if we were going to write what this means here, we would say that you're going to reflect triangle ABC across the y-axis, then translate it. And if you want to say triangle A prime, B prime, C prime, you're going to translate that new image 3 units left and 5 units up. Okay, so you do the first one, then the second one. You work from right to left. Okay, so here's our second one. You're going to be performing the rotation first, followed by the reflection. So we would say we're going to rotate triangle ABC around the origin 90 degrees. Okay, or you could say counterclockwise 90 degrees. Then we're going to reflect triangle A prime, B prime, C prime, that new image points across the y-axis. Okay, so first you rotate, then we're going to take that new image A prime, B prime, C prime, and we're going to reflect it across the y-axis. Okay, so work from right to left, inside out. Okay, on the next page, we're just going to do the first half of it. So the first one, it says, if you were reading something that said you wanted to do a rotation of 270 degrees about the origin, followed by a translation of 9, -3, how would we write this in notation, or in math notation? So this is our first transformation. This is our second. But remember, when we're looking here, we write the first transformation second, the second transformation first. So you're always kind of working backwards. So the first thing we want to do is we want to rotate around the point O 270 degrees. You put your little composite symbol, composition symbol, and then we're going to translate it by a vector of 9, -3. So that would be how you would set up the notation for this, this specific composite transformation. Okay, the next one, a reflection over the x-axis. That's your first one. And then we're going to rotate 180 degrees. Work from right to left. So if you want the reflection to happen first, put that second. We're reflecting over the x-axis, followed by a rotation about point O, 180 degrees. And again, this little thing right here, it's like a circle. It's just a little circle that combines the transformations, says that you have a composition going on. Okay. The last one, this is literally just the same thing. It says, given triangle ABC, translate it by a vector of -5, 3, followed by a reflection over the x-axis. So if you want the translation to happen first, it goes second. So we put t -5, 3, and then the reflection over the x-axis is the first one that we write. Again, whatever you want to be done first goes second, and then whatever you want done second goes first. It's kind of backwards. Given triangle ABC, rotate it 73 degrees about O. So we're going to rotate around O 73 degrees, and then we're going to translate by a vector of 11, 9. Okay, and we write it just like that. Okay, so what I want you to do right now is have everybody grab the 3-4 worksheet or have it get passed out right now. So it says 3-4 Composite Transformation Practice. If you want to quick pause the video so that everybody can make sure they have it, that would be good. And what it looks like then, okay, the 3-4 practice is going to be looking just like this. It says Composite Transformations Practice. What I'm going to do is kind of go through one of these to kind of explain what you need to do, and then you will just have the rest of today to be working on finishing yesterday's assignments, making sure you have the paper one done. When you finish it, hand it in. Make sure you hand it in today before the end of class. And then the 3-4 worksheet, which again looks like this. And I am going to have you hand this one in as well. So the worksheet from yesterday and then the worksheet from today, they both need to be handed in before you leave, even if you're not quite done with it. So everybody needs to hand it in. Okay, so 3-4 Composite Transformations Practice. If you look at this, we have a front page and we have the back. There's a total of 6 problems. And there are no specific directions given there, so that's why I'm going to go through this so that you know what I'm expecting when I look at your papers. So, you are given a graph here, and it has a picture already drawn in there. ABC in this case is a triangle. When I go and look at this table right here, it has those 3 points in the table there marked. So A is at 0, 4, B is at 2, 4, C is at 3, 1. Those are the original points in that picture. It is going to give you right here some sort of composite transformation that you need to perform. So what you need to do is draw the picture in the grid and write down the ordered pairs down here. Okay? So when I look at this notation here, what I'm going to be doing is working from right to left. So first we're going to be doing this, the reflection, then we're going to be doing the translation. So what I'm going to do first is just write down here, transformation 1, transformation 2. My transformation 1 was reflect over the y-axis. And again, I like to use coordinate rules, so what I'm going to do, that coordinate rule of reflecting over a y-axis, you take your point x, y, and it becomes negative x, y. And so if I'm going to use that as my rule, I have it right there so that I can look back at it. My transformation 2 is that I'm going to translate by a vector -2, -3. Well, what that means is you're going to go left 2 and you're going to go down 3. Think back to translations. What did that mean? Left 2, down 3. The coordinate rule for that then, all it is we're saying x minus 2, y minus 3. So now what we can do is either do it in the grid or use your coordinate rules to find your new image points. So you want to find A prime, B prime, C prime, and A double prime, B double prime, C double prime. Okay, so the first one, reflect over the y-axis. And you don't have to use those coordinate rules. Again, remember, it's just another way to check. It's a different way to do it. You can use just doing it in the grid here. So reflect across the y-axis. We can clearly see that if we're going to reflect over that y-axis here, A prime is going to end up right where it started. B is 2 units from that line of reflection, so B ends up over here, B prime. C is at 3, 1. It's going to end up over at -3, 1. So I first have got that triangle graphed. Again, either do it by hand like I just did, or use your coordinate rule. So 0, 4 becomes 0, 4. It stays the same. When we compare up there, well, that makes sense because A is on the line of reflection. 2, 4 becomes negative 2, 4. Again, go check it. When I did it by hand, negative 2, 4, B prime ended up right there. C prime is at 3, 1, so it's going to become negative 3, 1. So negative 3, 1. Again, you can look up there, see that C prime ended up where it's supposed to. Now, the second part is a translation. So again, you can just take all of those points and translate them by that vector. So you can go left 2, down 3 for all of those points, or you can use the coordinate rule. So I'm going to take this point, the A prime, B prime, C prime, and that's what I'm going to use in these coordinate rules right here. So 0 minus 2, we're going to end up at a negative 2. 4 minus 3, we end up at a 1. Negative 2 minus 2, we're going to end up at a negative 4. 4 minus 3, we end up at a 1. Again, I'm taking these points and I'm sticking them in for x and y right here. So negative 3 minus 2 is negative 5. 1 minus 3 is negative 2. Okay. And then you just have to graph them. So go back up here. A prime is at negative 2, 1. Sorry, A double prime. B double prime is at negative 4, 1. So we have B double prime. And then we have C showing up at negative 5, negative 2. So you get a picture like that. Okay. And so when I'm looking at your papers, I'm going to be looking for, did you graph it in the grid? Did you write the ordered pairs over here? When I do these coordinate rules, that's just how I prefer to do it. So I would be writing those up here in these little boxes. If you're just doing it by hand, that's okay as well. Make sure to grab some tracing paper from the front. We are probably going to have just like a short one question quiz similar to this tomorrow. So be prepared to be able to show that you know what you're doing tomorrow. You'll be able to use your notes. You'll be able to use probably even this worksheet. Okay, but again, this worksheet is what you have to do the rest of today. You also have yesterday's if you never finished it, along with yesterday's ALEX assignment. Both worksheets should be handed in to the box before you leave, even if you are not done with today's 3-4. But yesterday's should definitely be finished because you had enough time in class to do that. Okay. Shoot me an email if you're stuck. Come in for help tomorrow if you are absolutely stuck. But otherwise, have a good day. Use your time here. If you happen to get done, you can go work on some topic goals. Okay. See you tomorrow. Bye.